Good day, YouTube. Back with another video here. And as you can see, this is a bead roller that I'm assembling here. And the reason for this video is that I'm still proceeding with the work on the 66 Impala. I just ran into an issue with one of the doors here, which had rough patches and bad surfaces on it with a lot of Bondo buildup. But upon grinding all of the Bondo, the metal on that surface door was just real bad. So this is just another step that I needed to proceed with here. Either I would have had to pay someone to do it, which would have been costly, or I figure out a way how to do it myself. I'm not a professional, but I'm just going to go along with it and do what I can. And that's what I do. I'm not a big shop, but if they can, I can too. Is my mentality. So yes, this is the bead roller that I purchased for one of the doors that I have on a 66 Impala. Upon sanding it down, it was just real bad, layered, caked up with Bondo, due to the metal beneath it just being warped and real bad. Now what you're seeing here is just patch panels that I kind of did around the panel to actually try to correct the surface, but I'm still not happy with it. So I've decided to actually cut out the whole surface panel of that portion of the door, and I'm gonna weld it. But now the areas where there is lots of warpage due to the surface heating, upon welding it kind of warped the metal to where it's just not as straight as I would like it to be or how it should be. So I ended up having to come up with a plan here to build my own bead roller. And that's the purpose for this video. I actually did some research here. I bought a bead roller, but as anyone knows, by hand, to actually try to feed a metal panel through a bead roller as a one-person type of project, it's just impossible. It's hard to be done. So I wanted to incorporate building a motor that would automatically feed the bead roller while I'm feeding the panel through the beads here. Now, in the beginning of the video, I did post all of the main sources where I did purchase these parts here, and everything was pretty much through Amazon. Now the foot pedal is optional. I find that it's not really necessary. It helps out, but the other components are the main components which I really needed to actually get this machine to work. Now I'm going to take you through the whole assembling process here. That way, for anyone who's probably interested in building their own bead roller, it's not really a difficult thing to do. This is not like a high-grade professional sort of bead roller to handle all sorts of metal. Now, further on in the video, you will see that the thickest sheet metal gauge that I was able to roll through the build that I have here was a 16 gauge. And I just kind of wanted to take the motor through the rigorous steps to see if it was capable of actually rolling a 16 gauge sheet of metal, and it did, which is not the gauge what I would actually use for the project that I'm doing here. I'm pretty much sticking with 18 or 20 because I find it easy to weld and also manipulate the metal for the project work that I'm doing here. But as you can see here, I'm just putting the wires together because I kind of want to dress it up to where everything is connected properly so I don't run into issues later on. So I want to make sure that they're nice and stable by heat shrinking the wires and also making sure that they're connected in the proper places, but also connected with durability so that it does not fall apart or become brittle uh, in times of use. Now, this is the speed control unit that I'm actually connecting to the motor that I have here. Now, before connecting the motor to the bead roller, how it did come, everything came in different parts, but which was kind of self-explanatory. As you can see here, it has a speed motor. It has the bracket that also houses the motor, which stabilizes it on the surface area where I would like to connect it. And I ended up buying a welding table that I got for a good deal off of Amazon. And my plan is to actually base these two components on the table so that I can proceed with my project here. Now, as you can see, that front bracket is connected. Just want to make sure that everything is balanced. And I also want to make sure the leveling is correct. That way I'm not stressing the motor out due to alignment issues. But what I'm doing here, I have it on a separate stand, the bead roller, just to test the machine out to make sure everything works as my vision, as the plan that I do have here. So I kind of just want to put it on the edge of the table, and I have the bead roller on a stand. And I'll get everything connected just to see how and will it work. So as you can see here, I'm just checking the alignment and also the adapter that marries these two individual pieces together, making sure that it's the proper size so that there's no fitment issues here. Now I'll base everything here and I'll screw it down. That way everything is stable, so I don't have issues with the alignment. But since this is a 300-watt motor, it does have force, so I need to tie it down on a base to where it's pretty stable so that it's not moving all over the place. So once this is tied down, this adapter piece that I have here, I'll pretty much lock it into position with the motor. And then I'll just bring the bead roller in to line it up. Now I want to make sure that it's leveled properly here. And as you can see, everything kind of fits into place. But it's not just a matter of fitting into place. You want to make sure that everything is leveled properly. And the more you could actually line up all of the parts here for this machine to work, it actually runs better, in my opinion. That way you're not causing wear and tear and just overstressing the motor out from doing its job here. Now, as you can see, the bead roller is locked in. The motor is locked in on a table here. And I'll pretty much just give it a test to see if it actually works. But before I do that, I kind of want to measure to make sure that there's no bad angulations here. So I'll line it up just to make sure that it's balanced. And as you can see here, look like that is successful. And then I'll get everything tied down here just to make sure that the motor works. But as you can see here, YouTube, this is just a simple build of a bead roller for those who actually want to get their hands in and kind of learn how to do things. I kind of want to review, preview, and also just make my own video to show how I did it for those who actually would ever think of doing something like this. There's a video out there that walks you through these steps as of how I did it. I actually never watched anybody else's video on how they did it, but this is just an idea that I did. I purchased a bead roller, and in order for me to actually bead that sheet metal, it just was not working. So I came up with the idea, why don't I just shop around for a motor to see if that would actually drive this bead roller, as I see that they do come, which can be pretty costly. And these bead rollers, they can run up to $6,000 to $3,000 from what I see from shopping around. So as you can see here, YouTube, I'm getting everything based on the table here. And I went to my local Harbor Freight and I purchased these two vices here. And I actually had to cut up some sheet metal just to level everything at the proper height so that the shaft from the bead roller and also the shaft from the motor where it adapts to the adapter is lined up properly here. And that's what I'm doing. I'm just making sure everything is set up, putting it together, because when a motor is running, one thing you do not want is some sort of angulation issue, because any issues can cause stress to a motor, and any stress that is brought upon to a motor, it's not going to last very long. But if everything is aligned properly, then the motor will go a long way to withstand the job that it has to do here. So I'm mounting everything to the table here, seeing to it that both structures are actually based how it should be, just for tough durability, because there will be a lot of feeding which actually causes more work and stress to the motor here. And I actually want to prolong this setup. And the good thing about this setup, it's not something that's permanent. It's something to where if I needed the space, I could actually take it apart. And when I need it again, I could put it back together. So as you can see in this clip here, YouTube, this is the 16 gauge sheet of metal that I'm feeding here. I would never actually feed this through a bead roller, but just to test the strength of the motor, I just want to see if it's up for the task. Now it requires a lot of pulling, not because the motor cannot drive the sheet, but the two beads that I have here, they're actually real tight closed in, which is actually stretching the metal. So I have to apply more force, which would have worked out better to feed the sheet if I did separate the two beads and then I just do a second pass after by closing the two beads. But just wanted to take it through the test of the durability. And as you can see, it did feed that sheet through with a tight spacing through the beads, which actually did not have to be a tight space because it required me to actually apply more force to get it to feed. But as you can see here, the motor is up for the task and it is feeding. So when it comes to my 22 gauge and my 20 gauge sheets of metal here, I should not have any problem at all. But as you can see here, with multiple passes, it's going through without an issue. Now to get that crease that I need for the door, I'm kind of just measuring the angulations and then I'm matching it up with the panel just to see if it lines up with the rest of the surface of the door here by just running my beads, and at the same time I'll lay it on there just to make sure the angle degrees are precise. Now it does have a lip that curls up only because this door has an oval outer shape, and the sheet metal that I'm running through, it's just a flat surface. So after that sheet is actually beaded, I would have to roll the sheet to get the angulation of the door here. But so far so good. The process is going great. This is my sheet metal of the replacement surface that I do want to achieve here. Now with buying this bead roller, I just thought it would be a good idea to purchase other beads. I may not never use some of them, but you never know when they do come in handy. So it's always a good thing just to have them as extras. Now as you can see, after that first bead is actually beaded, it does not take a lot to actually bead the second pass. Now I'm measuring to make sure that I have my lip at the right distance so I can have a perfect crease to where I would actually cut the sheet metal that I'm removing from the door panel to the sheet metal that I will actually be replacing that removal sheet with. So I want to make sure that everything is aligned. This is actually where I'm going to feed the metal, where I will taper it off, and I could keep a good line to actually feed the metal at a slow process so I don't get any bad angulations, because once it's beaded, and if it's not aligned properly, it's just a headache to hammer that area down to rebead it, because now the metal is stretched and there could be warpage. So I'm trying to avoid certain things that can happen so that this does not cause other issues with my sheet metal panel here. So as you can see, as I'm prepping here, this is the actual run that I'm doing for the panel that I will be prepping for the door. So before I actually feed this sheet through, I want to make sure that all of the markings are correct to where I will cut the other metal to actually weld this new piece of metal onto. So I want to make sure that the measurements are correct to where all of these spacings actually line up well, so that when I do weld, I don't have issues with alignment. Maybe towards one end, it's probably off by a micro space to where it just doesn't line up correctly. So I want to make sure that the lining is spot on. And this is just a measuring tool that I have here, which will allow me to run a straight line with the same amount of distance from one end of the sheet metal to the other here. And that's what I'm doing. So I'd say it's a little over 1/4 of an inch space line that I'm doing here, to where I would actually create the fold for the panel here, where it would join to meet where the cut is on the door panel. About 3/4 of an inch, I would say. And then from that point, I lined everything up with yellow tape. Now this yellow tape is my guideline. I'm seeing to it that both tape areas where I have tape rolled on the bead and also the panel, that I keep those two areas aligned and not veer out of the direction, but just keeping it straight. And so far so good. I didn't have any issues with running the metal through the bead roller, since this is a 18 gauge sheet of metal here. I could have used the 20, which would have made it more easier. Now just keep in mind, depending on how tight you have your beads close together, will depict how easy your sheet metal panel will roll through the bead. So I like to open it up a little just to create a fold, and then once I have a slight fold, I found that it made it easier for me to run that second pass, which actually gave me the curvature I was looking for. But now, as you can see here, I'm just removing the tape. And from the build of the bead roller here, you could actually see that I do have that actual fold that I was looking for this panel here. And as you can see, I'm just lining it up. Now, because the panel is still flat, but the door has an oval shape, it's still not aligned with the door panel. But the goal was to actually get that area bead rolled, and from that point I'll pretty much just try to shape it as close as I can to the actual shape of the door, and then I would be able to weld it. It's just difficult to try to weld and hold the metal to bend it, because it causes a lot of stress points over the metal. So I find that it's better to actually find the shape that you're looking for, and then from that point on, you can pretty much cut the panel to the size of the open area that you have on the door panel, and then we'll just do some tack welds there. Now, as you can see, it's actually coming together good, I would say. And this is it, YouTube. Make sure you guys follow me on Instagram and also TikTok on Ben66Win. I do other videos there also. Thank you, YouTube. Have a good day.